the record button. All right, so go ahead and do those problems. 1 5/8 plus 4.5. And then the second one would be 2 7/8 minus 4 1/3. How we looking? Anybody need any help? All right, are we good? Everyone looks so intent, so focused.
I definitely need a refresher.
That's
I'm
all right.
struggling a little bit.
All right, let's go over this. So for the first, when we're adding mixed numbers, regardless of if it's a mixed number or a proper fraction or a improper fraction, when we're adding fractions, we need common denominators. So what I'm going to do is just write this on top of each other. And I'm going to need common denominators. So let's go ahead, let's figure this out. All right. 8 is 2 times 2 times 2. 2 is just 2, so my LCM is going to be 2 times 2 times 2. So far, so good, everybody. Yes or no? Okay. So let me zoom out here a little bit. So now I need to build equivalent fractions. So here's what I'm really concerned with here. This 1 out front is just a whole number. So I'm not worried about that. I'm worried about the 5/8. So 5/8 equals something times a fraction, which it got to be 8 as a denominator. Like we've done this, I think, 40 or 50 times already. So this is going to be 1 over 1. Everybody agree with me there? So 5/8 stays 5/8. So this is still going to be 1 and 5/8. Now, the other equivalent fraction. What do I have to multiply 1/2 by?
4.
4 over 4. Very good. So that's going to give me 4/8. So this is 4 and 4/8. Did everybody see how I did that? Yes or no? Now let me ask you this question. Even though these are mixed numbers, did my technique change? Step 1, find that lowest common multiple. Step 2, build equivalent fractions. Step 3, which is rewrite, which is what I did. Okay? Step 4, or not even step 4, rewrite and simplify now. So I'm going to add straight down. 5 plus 4 is 9. Denominator stays the same. 1 plus 4 is 5. Now I notice here my numerator is bigger than my denominator. And I know all mixed fractions has to be a whole number and then a proper fraction. Am I right? So this I can break down into 5 plus 1 over 8. Actually, let's write it like this. 5 plus 8 over 8 plus 1 over 8. Because if you think about it, I have 9 over 8, which means I definitely have at least one whole number inside that improper fraction. The question becomes, what's left over? So this is going to be 6 and 1/8. Does that make sense, everyone? Are we sure? Because here's what I did.
It was that last step I forgot, the very last.
Oh, okay. So here's what I did. I kind of just threw you in the deep end to see what would happen. Because if you look, all of our previous examples, let me go back here. I'm going to get out my highlighter real quick. What do we notice about all of our previous examples?
They have the same denominator.
Yeah, they always had the same denominator. This is the first time. Let me scroll back all the way up. This is the first time where I actually had you find a common denominator with mixed fractions. And there's a point to this. There's a point that I really want to drive home, which is, did my technique change? Not at all. In other words, I can give you any type of fraction. You should be able to do it because the technique doesn't change. So now that we kind of know that, let's look at the second example. What was that second one? Because I had to erase it.
2 and 7/8 minus 4 and 1/3.
Thank you. So I'm just going to stack it. Now I know my denominators are different. So step 1. Let's do that LCM thing. 8 equals 2 times 2 times 2. 3 is prime. So my LCM is going to be 2 times 2 times 2 times 3, or 24. Now, step 2. We're going to build equivalent fractions. That's what the EQF stands for. Build equivalent fractions. So I start with 7 over 8. And I know my goal is to get another fraction with a denominator of an 8. Oh, sorry, wrong. I wasn't thinking. 24, my bad. So what am I going to multiply by? 3 over 3. Make sure you say 3 over 3. I know what you mean by 3, but say 3 over 3. It makes me feel good. So 7 times 3 is 21. So there's my first equivalent fraction. The second one is 1/3. My goal is to get an equivalent fraction with 24 as my new denominator. What do I multiply 1/3 by?
8 over 8.
Love it. 8 over 8. So 1 times 8 is going to be 8. So now what I can do is rewrite and simplify, which is step 3. So I'm just gonna write step 3 over here, but I'm not gonna fill it in. I have a Stevie-itis today. I can't write. Since you made fun of me that day, now I'm making fun of you back. So here we go. Let's write these equivalent fractions now. 2 and 21 over 24 minus 4 and what was it? 8 over 24. Does that make sense, everyone? Yeah? All right, so here we go. 21 minus 8. What is 21 minus 8? Is it 13? Yeah. So it's going to be 13 over 24. 2 minus 4 is negative 2. And I know it's completely reduced because the 13 is prime. How are we looking so far? Better? Can you breathe again? Yeah, like I said, even though, like I said, they're different numbers or different denominators, whatever, different fractions, the technique doesn't change. Who was I talking to yesterday? It was a student in my MAT080 course. And I told, we were talking about something. We were going over graphing and everything. And she made the comment, she goes, boy, it just seems like there's so much I need to memorize. And that kind of made me think. And I asked the question, well, what do you mean by that? Like, what are you memorizing? She's like, well, all these problems. I got to memorize these problems. And then as soon as she said that, I was like, okay. I go, you're studying math incorrectly. And she goes, what do you mean? I go, math is not about memorization. I mean, let's be honest. Have you ever heard me say, memorize this in this class? Not really. The only thing I ask you to memorize would be right here. Just know how to do those 3 steps. That's it. When you're adding and subtracting fractions, if you can do those 3 steps, you're going to be fine. Every problem is different. All you got to do is know those 3 steps. So, if you really think about everything that we've done in Chapter 4, which I'm going to be honest with you, it was a lot. Compared to the other chapters, it was a lot. I can already tell you what I will be testing you on. So maybe you want to write this down. this is our little review for the exam. All right, I'm going to probably add some things onto this, and I will give you a formal review. Like, I'm not going to just say this is it and never come back to it. Like, we'll do it again. You definitely want to know how to prime factorize a number. It's going to be on your test. Probably be the first question. Here's the number 60. Tell me what the prime factorization is. I think number 2 goes without, really without saying. Simplification of fractions. You got to know how to simplify fractions. And in order for you to be successful at simplification of fractions, what do you have to know how to do first?
Factorization.
You got to know how to prime factorize. Okay? 3. You better be able to convert between mixed numbers and improper fractions in both ways. So if I give you a mixed number, convert it to an improper fraction. If I give you an improper fraction, convert it into a mixed number. Four would be multiply and divide fractions. And then the 5th thing would be add and subtract with like and unlike denominators. That's it. Now, when I say add and subtract fractions or multiply and divide, that includes proper, improper, and mixed fractions. Like, when I say fractions, I mean all of them. So, 5 things. I don't think that's too bad, right? What do you think? Oops. So are there any questions with that? Any questions? All right. So I want to ask you a question. I do. Let me ask you a question. What is this? What was this one? 1 5/8, 4 1/2. Okay. We already did this problem right here. Is there another way we could have done this problem? Stevie, you're shaking your head yes, so please tell us.
You can make them into improper fractions.
Yeah.
And do the denominator and all that.
I love it. Did anybody think, maybe I can convert that into an improper fraction?
I actually did that with both of the problems. And then you started doing it that way, and I was like, oh yeah, we can do it that way.
Yes. So I'm going to throw this out there. We know, and I might as well just review this because I'm going to be testing you on it. Even though these two fractions are mixed fractions, nobody says that you can't convert them into an improper fraction. I mean, you could totally do that. So off to the right, let's try and let's see what happens. For the first, 1 5/8. Well, that's going to be denominator stays the same, and then you're going to take the whole number times the denominator, add the numerator. So what is that? 8 and 5 is what? 13? 13 over 8. And then 4 1/2. 2 stays the same, and then it's going to be 4 times 1 plus 1. So that's going to be 9 over 2? Oh, horrible. 5 over 2. Jeez.
Well, no, it's 4 times 2.
So I was right. I'm stupid and I don't know how to write things down. See that, everybody? As much as you think I'm perfect, and I know that's what you tell people. You're like, oh, my professor, he's perfect. I make mistakes. Right, Crystal? Oh, don't think I forgot about you today, Crystal. Because your problem I'm going to do today in class. All right? So, here's what we got. Instead of it saying 1 5/8 plus 4.5, why don't we just do 13 over 8 plus 9 over 2? Hold on one sec. There's massive trucks going down my street. I live on a street with only like 4 houses. That's it. And all the way at the end, the garbage men were backing up their truck and they knocked over a guardrail. So now they're fixing it. So anyways, the original problem was 1 5/8 plus 4.5. What we said was, why don't we just convert them into improper fractions? Maybe that'll make our lives a little bit easier. So, 13 over 8 plus 9 over 2. But once again, the technique doesn't change. You still need the lowest common multiple. Okay, you still need that. You still need to build equivalent fractions. So for the first one, 13 over 8, you already have 8. You already have what you need in terms of the LCM. So just multiply it by 1. It doesn't change. The second fraction, 9 over 2. You know you want an 8 as a denominator, so we're going to multiply by 4 over 4. 9 times 4 is 36. Step 3. Just rewrite it and simplify. 13 over 8 plus 36 over 8. Now, last time I checked, you write one big numerator with the same denominator, and then 13 plus 36 is that 49 over 8? But here's the thing. If you own a store, no, better yet, I own the store. So I own the store and you came in to buy a stapler. And this stapler is $15, right, Kim? It's $15. Very expensive stapler. And you handed me a $20 bill. And I handed you back 25 won. Now, won is the currency in Korea.
Okay, that's what I was just about to say. Like, what are you talking about?
Yeah. Won is a currency in Korea. Now, Kim, wouldn't you kind of look at me a little funny?
Definitely.
Why would you look at me funny?
Because that doesn't make sense.
No, you gave me dollars. You're expecting dollars back. Am I correct? And here's why, if you do this method, it's fine, but you got to do something. You got to do one more thing, which is I gave you the original problem as a mixed number. I'm expecting a mixed number as an answer, not an improper fraction. Does that make sense, everyone? So the only thing that you would have to do is just one more step. Is give me the mixed number. 8 goes into 49. 6 times. Yeah, that's going to be 48. 6 1/8. My suggestion here is this. I don't care which way you do these problems. You could convert to an improper fraction like we just did, or you could just keep it the standard way, which is what we've been doing the entire time. Doesn't matter to me. Here's what matters to me. You got to make sure that you read the directions completely. Okay? Now, our class is usually really good at that, all right? My stats class that I'm teaching, not good at all. I am constantly fixing their answers for them because they do not read. And it's driving me crazy. It'll say something like round to the nearest decimal or round to the nearest whole number. Nobody does it. I don't know what happens. It's like we get selective reading all of a sudden. Your class is fine. Like, I've never had to do that once. So I appreciate that. But make sure that you're reading the entire question and the directions, even if there's like little parentheses there. Okay? Because it will tell you how does it want the answer. It'll say write your answer as a mixed fraction. Okay? Or it'll say write your answer as a fraction reduced in lowest terms. That means you could do anything you want. All right? Does that make sense, everyone? So please, just make sure you just read the directions. All right? Are there any other questions?
I have a question from the homework that I kept getting wrong, and I don't know why.
Oh, and when I asked, are there any questions at the beginning of class, Kim, you were late.
I know. I was
Bad news bears.
I was waiting for you to be done talking. I didn't want to.
Bad news bears. Let's see here. Yeah, what is that question? Does it go with what we're doing right now?
Yeah.
Okay.
And it's a little more hard, I think.
Okay. What is it?
Okay.
Because Crystal has a question too, but I'm not going to do that until the end.
Okay. Are you sure?
Yeah.
Okay. So it's 3/4 plus 1/2 on top over 5/6 minus 2/3. And for some reason, I just kept getting -3.
Okay, we'll do it. We'll do this one. Okay. So, let me see here. Who can I pick on today? Somebody without a camera on. So if your camera's on, you're not going to get called on. We're not many people. Everybody starts putting cameras on. All right, let's. That was great. Let's see here. Hey, here's something really interesting, everyone, while I'm trying to pick on someone. Elijah and I were standing in the same exact spot at one time at two completely different times in our lives in a completely different country. We learned that yesterday or the other day in class. Lakendra, are you driving? Yeah. Turn the camera off. I'm not calling on you. Be careful. That's on video, or it's going to be recorded now. Somebody's going to know this. Oh, jeez. Oh, man. All right, Lacey, are you here? Poor Lacey.
Yeah, I'm here.
All right. So what would you do in this situation, Lacey? Remember, there's no wrong answer. I'm just asking. So what?
Maybe find the lowest common denominator?
For what?
For 4 and 2.
I agree with you 100%. So what we're going to do here, all right, let's just focus on the top here. Let's just focus in the numerator, okay? So if you need to, get out a little piece of scratch paper and just write 3/4 plus 1/2. Now, I think this one's small enough where we can kind of see what the common denominator should be. It should be a 4. So I'm just going to write 3/4 plus 2/4. Okay? Now, when I do that, now I have common denominators. 3 plus 2 is 5. So this is going to be 5/4. So that's what I put up here. So far, so good, everyone? All right. Now, I need to do the same exact thing in the denominator, in that 5/6 minus 2/3. So 5/6 minus 2/3. Okay? So in this situation here, now I'm just saving some time here because I need you to start practicing how to find common denominators, all that stuff. So this is going to be 4/6. All right? I just have a lot of practice. I can see what it's going to be. So 5 minus 4 is 1/6. All right. How are we looking so far, everyone? Kim, do you see what's going on? Do you agree with what I have? All right. Now, we're going to pick on Kim because this is your problem. I have a fraction divided by a fraction. How do I do that?
Okay, so now do I still need to find the lowest common denominator for
No.
those?
Nope.
No.
Nope.
Okay.
So how do we do this?
Okay, so write 5 over 4.
Okay.
Next to it, you're going to write divided by 1/6.
Okay, I'm 100% okay with that.
Okay, and then next you're going to rewrite it and write 5 over 4 multiplied by 6 over 1.
Perfect.
And then it's going to be 35 over 4.
Oh, you're breaking my heart. Okay.
Stop it. Why? 4. Why is that not 4?
Well, it is, but you're going to have to simplify 30 over 4, correct?
Oh, yeah. My bad. Okay,
So,
hold on. Before that, so you're going to mark the 4 out and put 2, and then the 6 out and put 3.
all right.
I forgot you wanted to.
Yeah, you are moving way too fast.
I know.
You do it all the time.
I got it wrong.
So I break down the 4 and I break down the 6.
Yep, I know what I did wrong. Okay, so you're going to mark a 2 off and a 2 off. So then, yeah.
You're still moving fast, but that's okay. So I write out one numerator in order, one denominator in order, and I simplify.
Yeah. 15 over 2. How the heck did I get negative 3? Okay.
I don't know.
Well, thanks.
Okay, good. And Lacey, thank you very much for helping us with this problem. I forgot to say thank you. Shame on me.
You're welcome.
All right. How are we looking so far, everybody? All right. So, how about we do this problem? You do it, not me. All right. Anybody get an answer yet?
Yeah, negative 11.
You broke up, Stevie. You sound like a robot there for a second.
All right, I got -11.
Negative 11. Anybody else get negative 11?
Yeah.
Kim got negative 11. Okay. All right. So how would we approach this problem? 1 minus 3 over 5 divided by 1 over 20.
What's it called? Order of operations.
Order of operations. Very good. So I don't see any parentheses. I don't see any exponents. Do I have multiplication or division? So I have to do that first. So that's going to be right here. So this is 3/5 divided by 1 over 20. I know I'm going to rewrite everything 1 minus 3 over 5, except that division changes the multiplication, and I write the reciprocal of the second fraction. Does that make sense, everyone? Another way you could have done this is just wrote it off to the side. Nobody says you can't do that. Okay? Now, before I multiply, I'm going to simplify first. $20 is 2 times 2 times 5. Now, I'm going to write one big denominator, or one big numerator, one big denominator in order. Okay? And then from here, I'm going to simplify. I can reduce the 5s. Does that make sense so far, everybody? So I get 1 minus 2 times 2 is 4, times 3 is 12. And then 1 minus 12 is negative 11. Does that make sense? Bless you, Kim. That was a big sneeze. Is it me, or is like one of the best feelings on earth a good sneeze? Like sometimes I sneeze so hard that I see stars. I'm like, whoa, that was a big sneeze. Crystal, does this make more sense?
A little bit.
All right, let's just recap it real quick. Oh, come on. There we go. First, just read the problem. 1 minus 3/5 divided by 1 over 20. You have to do the division first. Now, I could see the number one mistake I could see students making is 1 minus 3/5. They would do that first. Can't do that first. You have to do the division first. So that is dividing fractions, which means we need to know how to rewrite that. Then we simplify, and then lastly we solve. Or sorry, we don't solve. We just subtract. That's it. So the hard part here was just recognizing, order of operations. On a test, the directions will clearly state simplify by using order of operations. So I'm going to tell you, use your order of operations here. Okay? Are there any other questions? All right, so what I was going to do is I was going to go into section 7, but I'm not going to do that. I'm going to wait for that for Friday. I think we just need practice on just a bunch of different problems. Because if you think about everything we've done, it's always been, okay, here's exactly what we're doing today. And here's exactly what we're doing on the next day. Now I'm just going to jumble up all the different types of problems for us. All right? There's your first problem. Here's your second. I don't want to do that. Let's do it like this. First problem. Second problem. Third problem. So this is just a mixed practice. All these, they're all going to be different. So do you want to work on these together or separately? Alexis, you get to pick.
Together. Sorry.
No, that's okay. Together is fine with me. Together is fine with me. Now, together means together. Doesn't mean Mr. Float. So, first problem. 2 3/10 divided by 1/10. From a 30,000 foot view, what am I doing with these two fractions? Am I adding, subtracting, multiplying, or dividing? Which one?
Multiplying.
Technically, I'm dividing first, but yes, Kim, I'm going to rewrite this as a multiplication.
Okay.
All right? So in order for me to do that, can I do that the way the problems look? Or, I'm sorry, can I do this the way the fractions look right now? Or do I have to do something first?
You have to rewrite it.
Rewrite what?
The fractions.
Okay. What about that 2 3/10? Can I leave that the way it is?
Yes.
Okay. So 2 3/10 times 10/1. Now, can I multiply these the way they look right now?
Yes, but you shouldn't. You should reduce first.
I don't agree with that now, Kim.
Oh, God.
There's something I need to do first. Anybody see it? In fact, I would have done it before that step. What type of fraction is this?
I would make it improper.
Yeah, it's mixed. I can't multiply mixed fractions. I need to make it improper. So the first thing I need to do is convert to improper. So off to the right, I write a 10 and then 2 times 10 plus 3. So that's going to be 23/10. Does everybody agree with that? Crystal, were you going to ask a question?
Yeah, I was, so it would be 10 times 2 plus 3? Is that what it would be?
Isn't that the same thing?
No, I'm just saying, so that's the first thing I actually thought after Kim.
Yeah.
If
No,
that was okay, that was the first thing that came to mind.
yeah, you have to convert a mixed number to an improper fraction when you're multiplying or dividing. Okay? So now I can write the problem as 23/10 divided by 1/10. So I can apply my technique now. Rewrite the first fraction. Division changes the multiplication. And I will write the reciprocal of the second fraction. Now I can see something, right? I mean, right from here I can see something. Anybody else see it? What do you see?
10s can be reduced.
Yeah, those 10s are going to be reduced. I can see a 10 in the numerator, 10 in the denominator. So why not just scratch them out right now? And you're left over with 23/1, or just 23. All right, does that make sense, everyone? Okay. Second example. 5/9 minus 4/9. You got to take a step back. You got two fractions. What's the math operation?
And then just do denominator.
Oh, you're moving too fast. It's not what I asked. What's the operation between these two fractions? Add, subtract, multiply, or divide. Subtraction. Now that I understand, okay, it's subtraction, Stevie, what do I have to check?
Same denominator.
Same denominator. Are they the same? Perfect, they're the same. So all I need to worry about is just the numerator. 5 minus 1, or I'm sorry, 5 minus 4 is 1. There's something I did in both examples. Now, both examples are entirely different, but there is something I asked in both examples. Anybody know what that is?
What's the operation?
Thank you, Kim. Every single time you approach a problem, you got to ask yourself, what type of problem am I given? Okay? And I'm going to do the same thing in this third example. I take a step back. I can see the fractions. The question becomes, what am I doing? Am I adding, subtracting, multiplying, or dividing? Dividing, thank you. So, I look at it. I have a proper fraction divided by an improper fraction. I don't have to worry about converting anything. So I rewrite the first. Division changes the multiplication. And I multiply by the reciprocal of the second. Does that make sense so far, everyone? Okay. So now that I'm multiplying, I simplify first if I can. 7 is prime. It stays the same. 24 is 8 times 3, but I know 8 breaks down into 2 times 2 times 2. So 2 times 2 times 2 times 3. Now for the second fraction. 3 is prime, so it stays the same. 14 is 2 times 7. Now the reason why I did that is so I can write one big numerator in order and one big denominator in order. Now I'm going to apply my property of 1, which means I'm looking for numbers that are the same in the numerator and denominator. So 3 over 3, replace them with a 1. 7 over 7, replace it with a 1. The only number I have left in my numerator is 1 times 1, which is 1. And then my denominator is going to be 2 times 2 times 2 times 2, which is 16. Does that make sense, everyone? I really, really, really want all of you to do very well on this test coming up. All right? So let me give you some hints, okay? Flashcards or note cards. If you don't have them, take a piece of paper out of your notebook, fold it, and then cut it. So you can have like little, you can make your own flashcards. Here's an example of the first one. That should be on the front. Multiply fractions. Here's what should be on the back. All right, there's your first flashcard. So look at it, multiply fractions, and then you should think about, okay, simplify using prime factorization, cross out any numbers that are same on the top and bottom, multiply the leftovers. Second flashcard. Obviously should be divide fractions. Here's what should be on the back. Boy, it'd be great if I could spell on a Wednesday. So that should be on your back. 1, rewrite the first fraction. 2, change division to multiplication. 3, write the reciprocal of the second fraction. 4, follow steps for multiplication, which brings you back to that. Is this making sense? How many of us ever do this in math? Probably nobody. That's okay. Lakendra, I'm sorry, what did you say?
I said no.
Yeah. Math is, if you were going to the notes and replicating the problems, you were studying math incorrectly. This is what I'm testing you on. Okay? And here's the best part, everyone. My exams are open book, open notes, am I right? I mean, I can't prevent you from using that stuff. I'm not in your house. Wouldn't it be really weird though if I just like walked away from my camera and all of a sudden you saw me like standing behind Elijah? Or like I stuck my head like this way and my body's still here but my head's behind Elijah? That would be awesome if I could do that. But I'm just saying, I can't be there. So I'm not going to fight the battle I'm going to end up losing anyways. Because I know some of us are going to use our notes. In fact, I encourage it. But really, you can sum everything up on a couple note cards for every single one of my exams. So there should be 2 more note cards. What do you think they're going to say? What do you think this note card is? I would say add or subtract. And then the third note card would be something like mixed numbers or mixed fractions. Or on the back, I would have how to convert them. And then I would put like a little star. If I see these in any problem, I can convert to an improper if I wanted to. Like all that stuff applies. Does that make sense, everyone? Like I said, I really want us to do well on this next test. All right? So your next exam is when? Monday, right? So here's what's going to happen on Friday. On Friday, we're going to go over section 7, which is solve equations with fractions.